Welcome back to my series on mastering GenAI with MLflow. And today we're entering our third in the series, and today we're going to introduce about tracing. Now, tracing is not something new. Tracing has existed in the software engineering world for the longest time. We used to actually do tracing by explicitly or manually instrumenting our code. We may be writing printf statements in the early days, or we might print into the log file. And then more recently, we use logging tools, and we can actually allocate the levels of logging we want. We can actually do verbose logging. We can do just log any errors or warning messages and so on and so forth. So we have some accountability. We have something that tells us, that reveals us how the software is actually doing. But how does MLflow tracing actually help you in the world of GenAI? Because the GenAI workflows sometimes can actually have calls to the LLM, which can be a black box. But developers don't like black box. They want to have visibility. They want to have accountability. So we're going to dive into the world of tracing as an introduction and see how we can actually do automatically trace any particular framework that's integrated with MLflow, understand what a particular trace model is, and then view the traces in the UI to see if something went wrong. And more importantly, I think use the latest and the greatest MLflow assistant to be able to inspect the trace, to be able to recommend, and then do some root cause analysis of the failure. So let's get started. What you will learn in this particular tutorial is basically why and what is tracing and why it actually matters in GenAI world, and understand the nuances of what a trace model consists of. It consists of traces and spans, and how you can actually establish a hierarchy so you have a nice workflow that you can actually look into the UI, and how automatically with one line of code, you can actually capture all that data seamlessly, and how you can actually do tracing with other frameworks. And as I have indicated in my previous two tutorials on this particular series, that MLflow integrates with over 20 or 30 agent working frameworks. So we'll explore how you can actually use OpenAI as well as LangChain to do automatic tracing so you capture all the data that you actually need in your workflow. And then finally, we'll try to visualize some of those traces in the UI, and more importantly, debug traces using the MLflow assistant. So the prerequisite for this is a notebook that you actually have done, notebook 1 and 2. You know how to start a UI and navigate your way around it, and must have your API keys configured. So what is tracing in the usual sense of the word? Now, traditional experiment tracking like logging using printf statements isn't really enough for LLM applications, because some of the calls are kind of black box. You're making a call to the language model and you don't know exactly what's actually happening back there and what arguments were sent, how much time it took, unless you go into manual instrumentation. So you can actually do something like, I'm calling my LLM, you make a function call to the language model, it comes back. But what happened inside, how long did it take, what was sent, what was received is missed. You don't have the ability to do that without intercepting the call. And we provide you with a solution that with one line of code, you can actually do the instrumentation yourself. Now, the solution is obviously doing distributed tracing. And what I mean by distributed tracing is not necessarily the tracing is executed in a distributed manner, but rather the tracing functions that actually are calls to the underlying services are distributed. So you might have a distributed database to which you're actually talking. You might have a distributed file system from which you're actually reading something. You might have a distributed web service to which you're actually making a search call. So that's what we meant by distributed tracing. And here is an example of what conceptually a trace might look like. You could be having a trace RAG application that has multiple spans, and we'll get into what a span means. But I could have a span 1, which is a unit of operation. That is, I'm embedding a particular query. So given a particular query, I'm going to go ahead and embed that, and I'll get the output. So that would be span 1. My second span could be, I could be taking that particular embedded query and making a call to retrieve the document, either from a vector store or from some file system that understands embedding and has some sort of a hashing function that gives me that set of documents. And the third span could be that I'm taking the particular documents that I actually return. I'll take the query that was given to me and I'll give it to the LLM to form a final answer. So essentially a trace now is comprised of 3 spans, and each are different units of operation that actually are conducted in that particular trajectory. And what are the benefits? There are 4. Very simple. Visibility. It gives you a lens into what the MLflow workflow is doing. It gives you some ability to look at and identify some of the latencies if you actually have any issues, any bottlenecks that you actually might have within the span. It's good for debugging and tracing, so you can actually go straight to the source where it actually failed and somehow give you the ability to use token usage per operation. So you have an idea which of the span among the multiple spans within the trace is most expensive, is least expensive, which is the bottleneck, what you can actually do to improve that. And then finally, allows you the ability to inspect each and every input and output so you can modify, you can change the quality of that. So it's very important. Second thing I think I want to share with you is understand exactly what a trace is, right? What is a trace and what are the data associated with that? The core concept, as I said earlier, trace, as the name explained, is a complete execution of one operation from end to end. It represents a one request, or it could be an entire workflow. And most traces comprise of one or more spans and normally starts with a root span. And a span, you can think of it, is a single unit of operation within a particular trace. It has a begin time and an end time. It contains certain inputs and outputs. It has metadata associated with that. Could be tokens, could be a latency, could be a model name. And it can be in a sort of a hierarchical relationship with respect to the root span. And it can also possess certain additional metadata such as model name and number of tokens and temperature and custom attributes that you can actually assign. So those are kind of the data model for trace. Trace consists of span. Span can have multiple units of operation within a single trace, and you can have multiple traces because each trace is a single collective execution or an operation. Span types, again, are about 7 defined in MLflow. You can think of it as a chain type is a sequence of operation that you want to sequentially sort of execute. The output of one operation could be an input to the next one and down the chain. So that sort of gives the ability to execute things in a sequential manner, chaining the operations together. Think of it something very similar to how you would actually execute a Unix command using the pipe syntax. LLM language model is another span where you're actually making a call to the LLM, which is sort of probably the most frequent span that you actually see. Retriever is a general document retrieval. Mostly any RAG application you're actually writing, you'll be using this particular span to tag that particular operation. Again, embedding, very similar to RAG. You'll be embedding a particular query and converting that into a vector of real numbers, which will encode your query, and then it will look up in the database or in the vector database. Tool is just a generic function execution. These tools could be a set of functions that you have actually defined, or this could be a tool of functions that an MCP server gives you access to. So that would be your span that is defined as of type tool. Agent is like pretty high level, just like LLM. It is kind of the driver that's actually working out through the entire workflow and trajectory. And then finally, parser, again, is a general way to parse a generic intermediate input or even output for that particular matter. So here's an example of a trace which actually has a root, which is the top level one. And over here, we are starting with a span called agent executor, which is one that's kicking off this particular workflow. And then within the agent executor, you actually have the planning step. You could actually have a tool execution, and you can have a final response. So this would be sort of a typical workflow that can actually have multiple things underneath. All right, so let's go ahead and set up our environment here quickly. I'm going to execute this particular thing. Shouldn't take long. That just sets up the environment that I'm using my OpenAI keys. I'm using localhost, and I'm using the latest and the greatest version of MLflow. Now, before we actually get into the whole idea behind auto-logging or auto-tracing, I just want to sort of give you an illustration of what it actually means when you run your first trace and you're not using auto-logging. What is it you're actually missing? So over here, I'm just making a call, and I'm just printing some statements. I make my SDK completion create over here, log my file, give the tokens, and let's see what actually executes. So what we don't get, what we don't know is the exact timing of the call. We don't know what was the detailed request and response structure. There's no way to collaborate that with how it actually interacted with other operations and what the usual representation of that is. And if I go to my localhost to look at the trace, I won't see anything in there because I did not intercept and I did not track and I did not log. So if I go over here in my host and I can see I have an auto tracing And if I go to that, I don't have any traces available for me. So none of that was intercepted because I didn't use the auto logging to do the tracing. So you can see that it's not a good idea not to use that. So what's the solution? Well, the solution is very simple, right? What you do over here is then you enable this particular thing with just one line of code by saying, I'm going to use, since I'm using the OpenAI framework, I'm going to use OpenAI Autolog. And once I've enabled that and I run the same operation, you will see that now we actually have a tracing that has all the parameters that actually need all the interception that it's captured, model messages, response and content, token, latency, all is captured automatically for you. And one of the great things about running this in the Jupyter Notebook is that you actually get the output right here within the notebook that you can actually look at it. So I've got my completions, I got my model name, it tells me how much it actually cost, what my input and output was, what was the latency, what was the messages being sent, what were the attributes. You can see the benefits of using tracing just by one single call. And if I actually go over here and refresh that, I'll see there's one trace over here. It gives me the latency. I can look at the dashboard, no errors, thank God. Token usage, tokens per trace, cost over time. As you see through the notebook, this will start getting higher and higher as I'm using more of the calls. And then this gives you a nice little dashboard and saying how much the cost breakdown was for the entire trace or for the entire operation. My advice to you is always intercept the call using OpenAI. It creates a unique ID, and you can actually always go and look into the UI to see what it is. Single line of code, MLflow OpenAI log. All right, let's go to step 6, tracing multiple sequential calls. Now, normally your agentic workflow won't only have one call. You will have multiple sequential calls, which is the normal mode of operationalizing, and that's how you actually will be dealing with multiple sequential calls. So how do you actually do that? Well, it's the same idea. You enable MLflow OpenAI log right from the beginning, and then you just proceed as if you were using your agentic application. So here we are. We're executing the first call, which is I'm going to talk to the LLM to say, you are a helpful expert and I can answer questions precisely. My query is suggest one interesting AI topic for a blog post, right? Once I get that output, I'm going to again send that particular output to my second call, which is going to be tracked. And over here, I'm saying, go ahead and create an outline with this particular topic. And my final topic is that given the particular topic, go ahead and write 4 sentences for me. And all these are going to be tracked, and then we'll print out what the token usage was. But we'll also look at how it presents itself in the UI. So let's do this. We're going to run this sequentially, and I'm going to have multiple operations. You can see that I'm generating my particular topic, and I should get a response back. And I'll take that particular topic and feed it into my next call that's saying, here's a suggested outline. And then once I'm done that, my final call is going to be write an introductory paragraph for that. And it's going to give me that introductory paragraph. And voila, there I see, right? I have my 3 calls, as you can see. My first one, which was suggest one interesting topic for the blog. I got my input, my output, my token usage, my latency, all that is actually captured automatically. I go to my second trace and I get the same thing. What was the input? What was the output? How much did it cost for this particular trace? Breakdown. What was the latency? I can go to my third one and I see exactly the same. So I have 3 different traces. And the reason I have 3 different traces is because I had 3 different operations, and these were high-level operations that would automatically capture. If I go to my UI and I refresh that, you will see that I have traces altogether so far 4, and gives me the latency, the token usage, and what I've spent so far in 4 traces, which is very minimal given that I'm using a small model. All right, let's go back to our notebook. What's the next step? So the observation is that OpenAI creates this separate trace, but in the next book, we'll actually see how you can actually group all these related calls that do a single operation into a single hierarchical trace. And we'll do that by explicitly using a manual MLflow trace decorator, but that's until the next book. All right, let's go on to step 7, which is how you can actually do the same thing using LangChain. So we're going to see how LangChain is integrated, and all I have to do is exactly the same thing I did with my OpenAI, MLflow.langchain.autolog. Okay, so let's do that. I already have this LangChain installed, so I don't need to. just establishing importing some functions, and here I have LangChain autoload, and then I'm going to create a simple chain. And the chain over here is a way you can actually, for example, chain multiple operations using LangChain API to sequence those operations. Think of it as a Unix command. So my first level of operation is I'm creating a template for which I can provide the injection variables that I want, and this will be substituted when I make the call. So we say you are a role, which could be an agent or you could be a friendly assistant. Answer the following question. So that's my first thing. Then I'm going to go ahead and figure out whether I'm using my local provider or I'm using OpenAI. So I'll create the appropriate LLM object for that. And the third one, I'm going to create in this particular chain. You can see that this particular chain now is tied in together using the operator. And then I'm going to do the invocation of that chain, and then this will sort of execute this using LangChain operation. We'll make the appropriate call, we'll substitute the template with the appropriate injection variables, and then I'll get my response. So let's run this. So it's creating and running a LangChain with that particular tracing. It's enabled tracing, so it's intercepting all the particular call, getting the appropriate variables so you can actually track and load those into the MLflow database, and we should actually get an entire output. So you can see that my response tracing was, the prompt was substituted with the right variables, and I got the response from that. So what actually happened over here? We did the prompt template construction, and we injected the two variables, role and topic. The variable substitution was done at the time of invocation. I did my LLM invocation, and then all as separate spans within the hierarchy. So if I go to my particular UI, you can actually see that I had the root runnable sequence of LangChain. I had the first call within the span was the chat prompt template, which actually had another call, chat OpenAI, and then that actually called the completion. So I get my entire chain. You can actually see that in one particular trace, and it gives me the token count, and it gives me the latency, and all this fun stuff that I really want to look into. It's captured right there. So what are the benefits of LangChain? As I said earlier, it gives you the chain execution, see how the data flows through the entire chain using the pipeline operator. Prompt construction was done automatically. I just looked at a particular template and I used that template to do the variable substitution. And LLM calls are pretty standard using the OpenAI tracing. And these are quite important when you're actually using React components. And the tool user, if you actually had any tools. All without manual instrumentation, all just done with a single line of code, which is MLflow, library name, autolog. Last and the most fun bit that I really enjoy is error tracing and debugging. One of the great things that we have done to make the developer experience quite useful is the ability to somehow look at the traces not manually, humanly, but also have an MLflow assistant powered by Claude to be able to look at the trace, to do some root cause analysis, to give you the suggestions how to actually fix that, right? So one way to do that is when something actually fails, you can look at the particular trace in the UI, you can filter out its status by error, and you can ask Claude or you can ask MLflow Assistant, what would you actually recommend and how you fix it? So in order to simulate that, we actually had three kinds of scenarios that we are trying to emulate here. One is that we're going to have some sort of API request error in our first call, and we're going to run that, and we'll try to ask MLflow Assistant, hey, sort me out over here, what's going on? Right. The second one is a similar API call, which is a very valid function, which is a very valid common error that people actually make not realizing by putting either spaces not allowed in the function name or putting some other characters which are not recognized by OpenAI as part of the tool function calling. And the third one is more frequently observed by developers, is that you actually might have multiple steps within the pipeline, and one or two of them will be successful, but the third one actually failed. And since there is a progression of the output of one going to the input of the second, and the input of the second going to the output of the third, it's important to somehow do the validation. And in this case, we have a third one that actually crashes based on something that the first and the second succeeded, and we'll try to figure out why it is. So the first role over here is we have an invalid role, pretty generic. Somebody instead of using user and assistant, they sent in a robot as a role. And so see what happens over here. Obviously, this will result into a fault. But the thing to do is that we have an error scenario. We got an invalid role, and we got an error here. So a trace won't work, right? Because we got this particular error. So what do? We go to the trace. And I'm going to go ahead and do the filter. Select state. Equal to error. Apply. Okay, so we got this particular trace that actually had an error. We're going to click on it. As soon as we click on it, we get a particular trace. And we can see this particular trace now is in our MLflow Assistant. We're going to ask MLflow Assistant, why did this particular request fail and how can I fix it? So we go over here and we're going to ask it to say why it actually failed and give me a fix. Now this might take a little bit, but essentially what's it actually doing is going through this particular notebook to figure out what the particular trace is, what the code is. It's trying to fetch a particular tool, and it'll try to analyze what was called and where it actually particularly failed. Once it look at the particular trace, it's going to give you the root cause analysis to figure out how you can actually fix that particular problem. And this is really, really cool and important developer tool to assist you in debugging with your MLflow or with your GenAI traces for that matter. So as you can see, tool span goes to an expression detail. This will take a while, but you should be able to actually see it momentarily, the root cause analysis. And as you can see, we got the error right here, but normally you probably won't get it. You might not capture, or you might not print it out, and we see the error right here. So let's go back to our thing. So here we go. Wow, I love it. So why the request failed? Well, the trace shows a bad request error, and it tells you what the problem was. You sent a robot as a role, which is not recognized. These are the OpenAI messages that are allowed or honored or recognized. And then how do you actually fix it? By just changing that particular role to a system and then additional note of what it is. So this was actually a good way to look at the first one. Let's go on to the second one, which is very similar. What we're going to do is we're going to run this particular thing. We have a calling functions that is calling a weather, but it's actually giving a wrong kind of spelling, and see if it actually checks that. So it actually runs and say invalid tool function name because it doesn't recognize the function that was registered, or the MCP server actually had a tool, didn't recognize the call. So here we are actually going to go and get the function name. We'll go back now here to our traces to see what are the traces. Here we go. What's the weather in Paris? We're going to click on that. We'll get our trace, and MLflow actually has that. And let's see what we can ask it to see what is wrong with this tool definition. We're going to go back here and quickly run this to the MLflow assistant. That's going to examine the entire trace. It's going to look at the code. It's going to look at the notebook, and it will ascertain and debug and give you the root cause analysis along with what went wrong and how best to fix this. And this is one of my favorite tools. And we introduced that in 3.9, and it has really resonated with a lot of developers because, you know, we have been using Claude and we've been using all this. Oh, wow, look at that. All right, so here we get. What's wrong with it? Well, we identify the problem. Get whether has spaces in it. We don't recognize that. So what's wrong with that? The valid pattern is that you can actually use any one of these function names as part of the syntax. And so the recommendation is that you use the snake case or use the camel case or whatever is your preference, and how to fix that. So let's move on to the last but not least, and that's an important one, which is a scenario where we actually have a multi-step pipeline where the first two succeed, but the last actually fails. And how do you actually go about debugging that? So we're going to run that as a chain. I have a string output parser. I'm going to have some definition function that parses the integer. And then we're going to create a pipeline. So pipeline is now my prompt template. I have an LLM that I'm using as a parser, and I'm going to go ahead and execute that as a single pipeline, and I will have 3 steps over here. So we'll execute the first step, and it seems like the first 2 steps about parsing and calling were succeeding, but the last bit failed because we were not using the right way to extract or parse the particular response. So let's see what we can actually do. It suggests that we actually have the span 1 worked success, the span 2 worked, but the third span failed. Now this is one trace, but it has multiple span. So let's see what we can actually do. Let's just cut and paste this error here. And we're going to go back here and reload our traces. This is the trace that was just executed. It returned you tokens because it's partially succeeded, but last bit it failed. So we're going to go back here and ask the assistant to say which step failed and why did each of the step return value and how I can fix it. So this is going to go through the entire stack over here, entire function, to figure out where things actually went wrong, right? Was it the parse integer rating that actually failed, or something within this runnable lambda actually failed? And you will actually get the entire trace. As you can see, this is our entire trace that gives us input and output. I can look at what were the completions that were called, get another chat OpenAI call, and what the inputs, and this was the last one that actually failed. So you can actually see the entire chain here being executed, and we get the visibility on not only the first trace, but also all the different span. Oh, here we go. Okay, so we got something over here. Analysis, parse integer rating step failed because there was an invalid literal they were actually using with base 10. The failure cascaded up to runnable sequence, so it actually went all the way up to top because we didn't get the right response. And which step returned what, so we actually get the idea of what was returned correctly. And what failed was this part over here. So it actually tells us exactly where the error was, what function it failed on. Here's the root cause, and it gives you the recommendation to how to fix it. And so what are the best practices? What are the best practices for using tracing, as we actually covered? What are the do's and what are the don'ts? You definitely want to enable auto logging early in the development cycle, so you can actually have the ability to debug right from the start. You get an understanding of what some of the performance characteristics are. You also know how it actually costs you. Using tracing in all environments, whether you're using development, staging, or even debugging in certain production cases. Production sample traces depend on the volume that you actually have. Combine the trace with the experiment tracking, right? Associate those with experiment tracking. We covered experiment tracking in this second tutorial. So if you don't know what exactly that is, go ahead and review it. This gives you the how and why. And then tracing is an important way to identify performance bottlenecks, expensive operations, and understand the failure patterns, because remember, agentic workflows can be quite complicated, and it's an iterative process, and you have to be very diligent about looking at that. And then use the MLflow assistant to inspect, debug, suggest fixes, and go and fix them, and then repeat that cycle on and on. It's all about repetition. It's all about understanding and getting a lens into the things which are happening behind the scenes that gives you more visibility. So in summary, just to recap, we defined what tracing is about, how critical it is for GenAI, in particular how MLflow gives you and equips you with all the necessary tools to be able to do that, more particularly a single line of code that can automatically capture all the traces, all the spans, all the hierarchy, all the inputs and outputs associated with that. It gives you the ability to visualize, analyze in the MLflow UI, multi-tracing step flows, which are a common workflow in the agents today, and then integration with all the external frameworks such as LangChain. We saw how you can actually do that. And more importantly, how you can actually use and take advantage of built-in MLflow assistant that has the ability to look at your particular code, examine the trace, and give you the root cause analysis along with suggestions how to fix it, and some of the best practices to use in production. So I hope that gives you a good insight into the introduction of what tracing is, what it means in the GenAI context, and how MLflow can actually help you. And in the next one, we'll actually go more deeper into MLflow tracing with manual tracing, where you actually have more control, more granular ability to actually trace your functions that you actually write and give you more advanced observability capabilities. So thank you for joining me, and see you again for the fourth tutorial.